Hello everyone. Today we'll discuss about computers and functions of computers, its various hardware and properties of computers. Computers perform a wide range of functions which can be categorized based on how they process, store and present data. These functions are crucial for a variety of tasks in daily life, from simple calculations to complex data analysis. Below are the key functions of a computer. Input functions, the process of receiving data and instructions from an external source, that is a user or another device. How it works? Users provide input using input devices like keyboards, mouse, microphones, scanners and touch screens. This input data can be text, numbers, images, sounds or commands. Examples: typing a document using a keyboard, scanning a document to create a digital copy, clicking a mouse to navigate a web page, or speaking into a microphone for voice commands. Processing functions, the manipulation of input data to perform tasks or solve problems. This is the primary functions of a computer carried out by the central processing unit or CPU. How it works? Once the input is received, the CPU processes the data according to instructions provided by software programs. Processions can involve calculations, decision making, logic or transforming data into different formats. Types of processing: arithmetic operations, performing mathematical calculations like addition, subtraction, multiplication or division. Logical operations, making decisions based on conditions, that is comparisons like greater than, less than or equal to. Data conversion, transforming data from one form to another, that is converting a decimal number to binary. Examples: a word processor arranging and formatting text, a calculator performing arithmetic calculations, a video editing software rendering or encoding video files. Output functions, the process of presenting processed data to the user or another device. Output is the result of computer's work, typically shown through output devices. How it works? After the computer processes data, it presents the results through devices like monitors, printers, speakers or projectors. The output could be visual, auditory or printed. Examples: displaying a web page or a document on a monitor, printing a report from a word processor, playing music or video through speakers, showing a presentation on a projector. Storage functions, the computer's ability to store data either temporarily or permanently for future use. How it works? Data can be stored in primary memory RAM for quick access by the CPU, or in secondary memory HDD is SSD for a long-term storage. Stored data can include operating systems, software programs, user files and more. Types of storage: primary storage, volatile memory like RAM which temporarily holds data that is currently in use. Secondary storage, non-volatile storage like hard disks, SSDs and external storage devices that retain data even when the computer is off. Example: saving a document to a hard drive, storing application data in RAM while the program is running, keeping backup files on external drive and retrieving the stored movie file from a hard drive. Control function, managing and coordinating the operations of all other components of the computer system. How it works? The control unit, a part of CPU, directs all the activities within the computer. It interprets instructions from programs and ensures the right operations are performed in the correct sequence. Examples: the control unit fetching an instruction from memory, decoding it and executing it. Managing the flow of data between the CPU, memory and input and output devices. Coordinating the tasks in multitasking environments where the multiple applications run simultaneously. Communication function, enabling computers to communicate with other computers and devices over networks, that is internet or local networks. How it works? Using inter-network interfaces, wired or wireless, computers can send and receive data such as emails, files or messages. This function also supports cloud computing, allowing users to store and process data on remote servers. Sending an email or instant message over the internet, accessing a cloud-based application like Google Drive or Dropbox, browsing websites or streaming videos, sharing files between devices over a home network. Automation function, performing tasks automatically without continuous human interventions. How it works? Once programmed, a computer can execute tasks such as scheduling jobs, running scripts or automating repetitive tasks. Computers can automate complex systems from manufacturing process to data entry tasks. Example: scheduling a computer backup every day at midnight, automating financial transactions or report generations in an office, running industrial machinery through automated controls. Decision making function, the computer's ability to make logical decisions based on predefined conditions. How it works? Computers use logic gates, algorithm and decision making structures, that is if else statement, to choose between different courses of action based on input data. Example: a thermostat deciding whether to turn on heating or cooling based on the temperature. A computer algorithm recommending content based on user preferences. Spam filters deciding which emails to block and deliver based on keywords and patterns. right? These are the various functions of computer. Now I'm going to another topic, and that is what we call it as hardware of computers. Next one is memory of computers. Now in memory of computers, the first one is primary memory or main memory. Primary memory is also referred to as volatile memory, meaning it loses its data when power is turned off. It is directly accessible by the CPU, making it the first form of memory. It is used to store data that is actively being worked by the processor. Types of memory: random access memory or RAM. Function: RAM temporarily holds data and instructions that the CPU needs while performing tasks. It is fast and allows the systems to read and write the data instantly. Characteristics: volatile. RAM loses its content when the power is off. Dynamic RAM or DRAM. Most common type of RAM needs to be refreshed regularly to maintain data. Static RAM. Faster but more expensive than DRAM, typically used in CPU caches. Size: RAM capacity ranges from 4GB, 8GB, 32GB or more, depending on the application of needs, that is general use, gaming or professional workloads. Read-only memory or ROM. Function: ROM is used to store the firmware or the system boot instructions that are required when the computer is powered on. Unlike RAM, it cannot be easily modified. Characteristic: non-volatile, retains its data when the power is off. Types of ROM. Types of ROM is PROM, that is programmable ROM, can be programmed once. EPROM, erasable programmable ROM, can be erased and reprogrammed using ultraviolet light. EEPROM, that electrically erasable programmable ROM, can be reprogrammed electrically, commonly used for BIOS firmware. Functions of primary memory: restores the operating system while the computer is running, holds active data and program instructions currently being processed, acts as a buffer between CPU and the lower storage like hard drives. Key characteristics: need: primary memory is much faster than secondary memory. Volatility: most primary memory RAM is volatile, meaning it requires power to maintain its data. Capacity: is smaller than secondary memory, typically ranging from a few GB to a few hundred GB in performance systems. Secondary memory or secondary storage: secondary memory is non-volatile, meaning it retains data even when the computer is powered off. It is used for long-term storage of data such as files, programs, and the operating system. Secondary memory is slower than primary memory but offers much larger storage capacity. Types of secondary memory: hard disk, HDD or hard disk drive. Functions: a traditional mechanical storage device with spinning disk platters where data is stored magnetically. Characteristic: high capacity, common capacity range from 500 GB to 10 TB or more. Slower than SSDs due to physical movement of the read and write heads. Cost effective: SSDs are cheaper as per GB compared to SSDs. Solid state drive. Functions: use flash memory to store data, providing faster access speeds than HDD. Characteristic: non-mechanical, no moving parts, making them more reliable and less prone to failure. Fast access: data is read and written almost instantly compared to HDD. Most expensive per GB than HDD. SATA or SSD or slower or more common NVMe SSD, much faster, uses PCIe lanes. Optical disc, CDs, DVDs and Blu-rays. Functions: used for data distribution, storage and media playback. Characteristics: slow access speed compared to HDDs and SSDs. Less common, optical drives are less frequently used as cloud and USB storage have become more popular. USB flash drives. Functions: portable storage devices used for transferring files. Characteristics: non-volatile, data is retained without power. Is small and portable, typically range from 4GB to 256 GB or more. Slower than SSDs but faster than optical disc. Magnetic tape used in data backup. Function: primarily used for large scale data backups and archival storage. Characteristic: high capacity, can store huge amounts of data. Very slow, accessing data on magnetic tape is sequential, making it slower than other forms of storage. Functions of secondary memory: restores the operating system, applications and files, retains data when the computer is turned off, provides the capacity needed for long-term storage. Key characteristic: non-volatile, data remains intact even when the computer is powered off. Capacity: significantly larger than primary memory, typically ranging from hundreds of GB to several TB. Speed: slower compared to primary memory, although SSDs can offer speeds approaching those of RAM in some cases. Comparison of primary and secondary memory. Now you see the primary and this is the different features: primary memory, secondary memory. Speed: very fast, this is slower. This is capacity: limited GBs and large GBs to TB. Volatile except ROM and non-volatile. Access: directly accessed by CPU. Indirect, requires IO operations. Cost: more expensive per GB, cheaper per GB. This is secondary memory, this is primary memory, right? Purpose: temporary storage for currents and long term data storage. Primary memory, RAM and ROM, is first used for temporarily storing data that the CPU needs right away and is essential for running applications and processes. Secondary memory, HDD, SSDs, etc., offer high capacity permanent storage for data, applications, and operating systems, but is slower than to access than primary. Together, primary and secondary memory work in together to ensure efficient data processing, storage, and retrieval in a computer system. And the next part that we deal with is this one, that is hardware. Now we will deal about hardware. What is the difference between hardware, different parts of the hardware and different parts of the CPU. We will learn about it, and we will do the practicals also in the next video. You can see the practicals of hardware and also how to assemble the computer system, right? Now we will deal with the next one, that is hardware of computers, right? Now, in hardware of computer, you can see these are the various features we can use. That is, first one is central processing unit, the brain of the computer that processes instructions from programs. Key features: clock speed measured in gigahertz determines how fast the CPU can process information. Cores: more cores allow multitasking. More common configurations include dual core, quad core, hexacore, etc. Threads: virtual cores that allow parallel processing. Cache: temporary storage inside the CPU for quick access to frequently used data. Popular brands: Intel Core i3, i5, i7, i9, Xeon, AMD Ryzen series. Motherboard function: the main circuit board that connects and allows communication between all components. Key features: socket type determines compatibility with specific CPUs. LGA 2000, 1200 for Intel, M4 for AMD. Form factor: physical size and layout. ATX, micro ATX or mini ATX, ITX. Chipset determines what features the motherboard support. USB ports, overclocking, PCIe lanes, etc. RAM slots determines how many memory sticks you can install and their maximum supported capacities. Expansion slot, PCIe slots for graphic cards, network cards, etc. Random access memory, RAM, temporary storage for data that the CPU is currently using. Key features: capacity measured in GB, 8 GB, 16 GB, 32 GB. Speed measured in megahertz, that is 2400 or 3200 megahertz. Higher speeds means faster data access. Type: DDR4 is common, but DDR5 is becoming more prevalent. Latency: lower latency generally improves performance. Storage devices functions: store data permanently. Types: hard disk drive and solid state drive. We already discussed about it. M2 drive, that is a form factor for SSDs, often faster than using NVMe protocols. Key consideration: capacity 128, 512 GB, 1 TB, etc. Read and write speed and form factor: 2.5 inches for SSDs and M.2 for newer SSDs. Graphic processing unit or GPU, graphic processing unit, handles rendering of images, videos, and 3D graphics, essential for gaming, video editing, and some specific computations. It types: integrated graphics built into CPU, Intel UHD graphics, AMD Radeon Vega. Dedicated graphics, separated cards, NVIDIA GeForce AMD Radeon. Key features: VRAM, video RAM, the amount of memory on the GPU, 4 GB, 8 GB, VRAM. CUDA cores or stream processors determines processing power for parallel tasks. Clock speed affects how fast the GPU renders. Power supply unit, PSU, provides power to all components. Key features: wattage determines how much power it can supply, 500, 650 or 850. Efficiency rating: higher ratings 80 plus, bronze, gold, made platinum indicate better energy efficiency. Connectors ensures compatibility with your motherboard, GPU, and other components. Cooling system functions: keeps the CPU, GPU, and other components cool to prevent overheating. Types: air coolers and liquid coolers. Use fans and heat sinks to dissipate heat, that is knock to a cooler master. Liquid coolers use water loops to transfer heat away, more efficient but complex. Key features: heat dissipation measured in TDP, noise levels, and compatibility with your case and motherboard. Computer case, chassis, houses all the hardware components and ensures proper airflow. Key features: form factor compatibility, ATX, mini, micro ATX, mini ATX cases depending on the motherboard. Cooling support, fans and radiators, mounts to airflow and cooling. Cable management for neat and efficient internal organization. IO ports, USB, audio, and other ports at the front for easy access. Input and output devices. Monitor displays the graphical output from the computer. Key features include resolution 100p, 1440p or 4K, refresh rate 60 Hz to 144 Hz, and panel types IPS, TN, OLED. Keyboard and mouse. Peripheral devices for user input. Mechanical keyboards are popular for gaming, while optical mouse offer better precision. Speakers and headphones. Output audio from the computers. Network interface card. Function provides connectivity to networks either through Ethernet or Wi-Fi. Key features. Ethernet port supports wired internet connections, typically 1 Gbps or higher. Wi-Fi adapter allows wireless connectivity, supports Wi-Fi 5, Wi-Fi 6. Optical drive function reads and writes data from CDs, DVDs and Blu-ray discs. Usage less common due to rise of digital downloads and cloud storage. Operating system function the software that allows users to interact with the computer hardware. Popular choices are Windows, Mac OS, Linux distributions, Ubuntu, Fedora, etc. Key feature determines hardware compatibility, security features and available software. Peripheral devices. Printer output physical copies of digital documents. External drives, portable storage options for backups and extra space. Webcam used for video communication and recording. Now say input, it receives data and commands from external sources, typing on a keyboard, scanning a barcode. Processing manipulates and processes data to perform tasks, to solve problems or calculating a sum in a spreadsheet. Output presents the processed data to the user or another system, displaying a report on a screen. Storage stores data for immediate future use on a photo or on a hard drive. Control manages and coordinates all operations and devices in the system, directing the CPU to execute instructions. Communication sends and receives data between computers and networks, sending an email, downloading a file. Automation automatically performs repetitive or scheduled tasks, automating software updates. Decision making makes logical decisions based on input conditions or data, sorting emails into folders automatically. Computers perform these functions seamlessly, allowing them to execute complex tasks, handle data processing, and serve a wide variety of user needs in fields of education, business, science, environment, and more. Information. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video. In the next video, you can see the various functions of various videos on hardware of computers and the assembling of computer system.